broad field with diverse applications, but fundamentally, our work is about infrastructure. Now, infrastructure is a term we hear a lot these days, especially concerning its poor condition in the United States. Some examples of critical infrastructure include systems that provide potable water, including water storage, treatment, and distribution, flood control systems, including levees and dams, wastewater treatment needed to keep contaminants out of the environment, including groundwater supplies, buildings of all sorts used for housing, business, manufacturing, entertainment, etc., transportation systems, including roadways, bridges, airports, railway systems, power generation and transmission, waste contaminant systems, which isolate municipal and industrial waste from the environment.
All of these infrastructure systems are vital for our economy and the functioning of our society. Their continuous operation is essential. Unfortunately, the investments our nation made in infrastructure in years past, which built our network of dams, highways, and countless other systems, are not being made today. The American Society of Civil Engineers gives our nation's infrastructure a grade of D+. This occurs in part because we tend to overlook these systems, taking them for granted. We are reminded of the importance of infrastructure when it fails. Examples include New Orleans, which was struck by Katrina. This led to failure of flood control systems. New York and New Jersey, struck by Hurricane Sandy, again a failure of flood control systems. And the Fukushima nuclear power plant in Japan. In that case, a loss of power supply removed the ability to maintain a proper temperature in the reactor core. The loss of power supply was from the 2011 Tohoku earthquake and the resulting tsunami. This video provides 4 examples of infrastructure systems to give you an idea of the type of projects you might work on within this field. These systems that we'll review include potable water treatment, earth dams and geotechnical engineering, transportation systems, and buildings.
Hydrology is, the way I describe hydrology is snowpack. We take snowpack when it melts, we capture it, and then it delivers to the city. The Van Norman facility is a big treatment facility. It has a capacity of 600 million gallons per day, so that's a lot of water. So we serve a big area, we serve 4 million customers. What we do here, the water comes in and we treat it. Civil engineering is very broad. We could be building buildings, bridges, to hydraulics, to environmental, to the more chemical end. So that's where this is more on the environmental front of the civil engineering.
This is a very happening time to be an environmental engineer. Our expertise is needed in all aspects of green city design. Every year our population increases, there's rapid urbanization, there is decaying infrastructure that needs to be upgraded, there are emerging air and water quality problems, health concerns, new chemicals in the environment, new pathogens. We're all going to need environmental engineers. I got interested in the environmental side of things, again from public health concerns and trying to improve quality of life. So my research focuses on understanding the interactions of emerging compounds around us with microorganisms, and that has implications from understanding toxicology to disinfection of water to bioremediation of contaminated soil, water, sediments in our environment. To everyone, don't follow the crowd, follow your heart. If environmental issues are something that you care about and you happen to be good in science and math, environmental engineering is a great combination. It's a great place to be in, and you get to interact with a lot of fun people, do challenging assignments, and really grow as a professional and as a scholar.
Geotechnical engineering is a branch of civil engineering, and it is looking at the behavior of earth-based materials, so looking at soil, rock, and things of that sort. Van Norman Complex, where we're actually standing here today on top of Valley Res Dam, is probably one of the most studied geotechnical sites in the world. Now, why is that? Because back in February 9th, 1971, there was almost a disaster that would have been probably historically one of the worst dam disasters in the world. It was the Lower San Fernando Dam. That day, there was some liquefaction in the foundation, and we had an upstream failure of the dam. Pretty much, if you look at all facilities, you look at a big building, a big skyscraper, it all starts from the geotech. If you look at even a small water tank, it all starts from the geotech. So the geotech will always go out and pretty much will always pick the site for the structural engineers, per se, and then at the end, based on that, they'll go ahead and decide if they want to put that facility or structure there. So for those who Tonka Tories, basically all the kids who play in the sandboxes, there is a field for you, and it's basically it's geotech.
Transportation engineering is when you design systems to get people from point A to point B. This involves designing roadways, designing freeways, designing bus rail, subways, even airways. Any way you can get someone from one place to another, that's transportation engineering. And civil engineers have a very integral part in designing those kind of infrastructure. Los Angeles has the second largest population in the United States with the third largest transportation system. So where I'm standing now is the subway station for the Wilshire Vermont Red Line station. There's been some new movement in urban planning which calls for mixed-use development. This LA Metro bus station is an example of mixed-use development. It combines residential, public transportation, and commercial spaces. This allows people to live and work in the same place and have easy access to public transportation.
Everyone uses transportation systems on a daily basis, so it's really important for bright young engineers to study transportation engineering so that we can develop more efficient ways of bringing people from one place to another.
Well, the basic process that goes into designing and constructing a project first starts with an owner who decides that they want to have a building that does something for them. And once that's done, then the architect and the rest of the design team, which includes the structural engineer, work together to try to develop a concept that allows the building to meet the budget, the functional requirements, all the things that the owner is interested in, as well as trying to make the structure look good. Once that's done, the design is then refined or developed from this basic concept into drawings that are detailed enough that a contractor can use them to build the structure from.
The Wilshire Grant project isn't just any ordinary office or hotel tower. It is destined to become the tallest building west of the Mississippi River. Now, that's a feat in and of itself. However, it incorporates all of the latest technology and seismic design and is a really groundbreaking project for Los Angeles. Right now, behind us, you have still in the bottom portions of it, the traditional reinforced concrete structure is still under construction. So it's getting near about at the ground surface now. So that's the lowest most portion of the project. Then you have the tower itself. The first part of the tower, of course, became very famous when it became the largest concrete pour in world history. 17 feet thick of concrete was placed under the tower. The structural engineers working jointly with the architect and the geotechnical engineering and so forth, they had to come up with a system that met the requirements in the city of LA for a high-rise building. Well, Los Angeles historically hasn't had as tall buildings, partly because the building code did not allow for very tall buildings until relatively recently, in the 1960s, that started changing. And in fact, I would anticipate we'll have built a lot more in the next 50 years.
I think the future of structural engineering is exciting in many areas. As we become more and more dense in our urban environments, I think that we'll see taller and taller structures. And I think that trying to combine the demands that we see from earthquakes and wind is going to lead to other methods for designing. I think an important piece of advice that I would give to future structural engineers is to make sure that you have a love of buildings. I think that work is a challenge and it occupies a tremendous amount of your time, and I think that you need to be passionate about what you're doing, because otherwise it's not going to lead to a fulfilling career, and you spend too much of your life working to not make it fulfilling.
The Civil and Environmental Engineering program at UCLA is organized to provide fundamental knowledge and practical, hands-on laboratory skills and design skills that are needed for engineers entering the industry. Our students gain specific knowledge and skill sets in several subfields within civil and environmental engineering. These include environmental engineering, hydrology and water resources engineering, geotechnical engineering, structural engineering, and transportation engineering. The video also introduces a few of our undergraduate and graduate students in the projects that they work on. These projects serve to enhance their technical skill set, their interpersonal skills, their ability to work as a team, and in many cases the projects give them a chance to form connections with design professionals in industry.
Here at UCLA there's a good community of undergrads that are really interested in this research. In a few years, engineers will be actually using the recommendations we make, maybe using some of our models, maybe even using some more innovative designs that we suggest.
Joining student groups is such an important thing for us as growing engineers. It allows us to use our skills in the classroom and apply them in real-world situations. It allows us to further our project managing skills and learn an environment that we wouldn't otherwise have in the classroom alone.
Engineering, I feel, has the stereotype of not being too social. I think that engineering groups and student organizations as a whole is something very beneficial to become involved, to become active, and to do the collaborative work that you may not be able to do in your lectures or in your coursework. So student organizations will get you that experience where you need to go.
Civil and environmental engineering is a vitally important field that many talented and dedicated professionals find to be very rewarding. Perhaps this is the field in which you belong as well.